Hey guys, so this is going to be part 5 of our Intros to Electricity in Circuits unit. Some essential questions we're going to answer during this lesson. First thing we're going to do is just quickly review Ohm's law and resistor values from last week. 2, what is a breadboard and how is it used? And 3, how do we build a working simple circuit? So I'll actually walk you through the steps to build a circuit in real life. So just as a review of Ohm's law states that current through a conductor between 2 points is directly proportional to the voltage across the 2 points. And using this statement, we can create 3 different equations to be able to calculate voltage, current, and resistance using Ohm's law. We have V equals current, so voltage equals current times resistance. And remember that current has the symbol I. We can say that current is equal to voltage divided by resistance. And we can say that resistance equals voltage divided by current. Also, last week we talked a little bit about resistors. So the value of resistors are determined by colored bands. This is the particular resistor color code chart that I like to use. I've linked this exact chart on your worksheet as well, so you can kind of use this. I think it's the most simple, easiest to understand, since we are primarily only using 4-band resistors. There are resistor color charts for 5-band resistors, 6-band resistors, but we really only stick to 4. So this is the most simple, easy to use for you guys. So just as a quick example, because you're going to be working through determining the value of some resistors on your worksheet this week. So if we had this resistor here, the first color band is blue. So that first color is represented by the number 6. So this is band number 1. Go down, it's blue. The digit is 6. Then we have gray. So we're going to go to our column where it says band 2. Gray is represented by the digit 8. And if you look just here in the color code chart, under the column for band 2, we can see that gray is 8. And then in 4-band resistors, the third color is the multiplier. So we're actually going to skip this column here and go right to the multiplier. So we see that that third band is red. The multiplier is 100. So essentially you're doing 8, so 68, times 100, and that's the value of the resistor. So this particular resistor, blue, gray, red, has the value of 6,800 ohms. You don't necessarily want to leave it in this form here. You kind of want to make it into its simplest form. So 6,800 ohms can also be 6.8 kiloohms. So you're going to want to put it in kiloohms to get rid of all those zeros at the end. Again, I understand that this is a little bit confusing. We're going to be doing some practice this week. Hopefully it gets a little easier as we're moving forward. So we haven't really talked about breadboards yet. Some of you may have used a breadboard in the past. This is just a picture of a pretty small breadboard. It's kind of confusing because there's a lot of like symbols, letters, numbers on here. So I'm just going to go through kind of how the breadboard is wired per se, or how things are connected within a breadboard. So the first thing I want to talk about are the horizontal holes within the centers of the breadboard. The 5 holes in each horizontal row. So we have rows A through E, and then we have rows F through J. So those separate sets of 5 holes that run horizontal are connected electrically through metal strips inside the breadboard. So all the pins, we call them pins, all the pins in row 1 are connected. All the pins in row 2 are connected. All the pins are in row 3 are connected, and so on and so forth. So when we're building a circuit, I may tell you to put one side of the resistor in pin D3. So you would go up to the column, find the letter D, go down to pin 3, and that's where you would plug in the resistor, for example. So if one side of the resistor is in this pin here where my mouse is, technically that resistor is connected to every pin in this horizontal row because there's a metal strip underneath the plastic here connecting all those pins together. We also can't talk about breadboards without talking about the two outer columns of the breadboards. So the vertical strips that run the length of the breadboard are electrically connected, and they're used for power and ground connections. So power, hopefully this is kind of self-explanatory, but power you would plug into one of the positive pins, so that's red on the breadboard. And ground, or 0 volts, you would plug into one of the pins located on the blue kind of column of the breadboard. So if you had a battery and you were creating a circuit on this breadboard using a battery, you would plug in the red wire of a battery to one of the positive pins and the black wire of the battery to one of the negative pins. So if I plug the red wire into this first pin from a battery, technically there's power, or 9 volts, for example, if we were using a 9-volt battery, there's 9 volts on every single one of these pins in this row. Because just like the pins in the inside of the breadboard, all the pins going vertically on this positive side of the breadboard are connected with a metal strip as well. So if we plugged power or 9 volts into this first pin, there would also be 9 volts in this pin here. Same goes with the negative side of that strip of the breadboard. And lastly, in the middle of the breadboard, there's a middle row that breaks the connection between the two sides of the board. So, for example, pin A1 is not connected to pin F1 if we were looking at these pins. This kind of breaks the connection. There's not a metal strip that runs all the way through. There's only a metal strip between these 5 pins, and then there's a middle strip between these 5 pins. So you can kind of separate different parts of a circuit to different sides of the board.
Hi, this is David with Creation Crate, and this component is called a breadboard. A breadboard is also known as a prototyping board. It's a thin plastic board that's full of holes that's used to hold components that are wired together. It's commonly used for prototyping and experimenting with circuit designs, so you don't have to solder everything together and make it permanent. You can kind of pull it apart just like Legos and put it back together in a different configuration until you're satisfied. Now, on a breadboard, you'll notice that there is a horizontal row here that's labeled negative and another one below it labeled positive. So I usually jump a current into here to give power to my board. Once I jump current into one of these holes, then this has a negative current and this has a positive current that I can then jump into another one of these holes in the middle of the board. Now the middle is a little bit different. First of all, there's a separation here. So these are connected together, these are connected together, but this is a separation in the board. These are also connected vertically instead of horizontally. So these 2 rows are connected horizontally, and all of these are connected vertically. Now the breadboard again is used for experimenting and prototyping.
So like just explained in the video, breadboards are a simple way to take circuits and electronics projects to the next level. It allows you to do some prototyping before you actually permanently wire components together. So just in this example here, we have a battery that is powering 4 different LEDs using resistors. So you can do some kind of prototyping on the breadboard, like I said before, permanently soldering your components together for a project or something you're trying to build. So this is a simple circuit on a breadboard. I know it looks kind of different because this battery pack has a switch actually wired into the battery pack, but essentially it's the same thing. You have the battery, like we talked about in a simple circuit. You have a battery, you have a switch, which is the control, you have some sort of LED with which is the load. You always need a resistor with some sort of LED, and this is built on a breadboard. So we're kind of going from drawing a simple circuit in a schematic diagram to now using real life components to build that circuit and see if it works. So I just quickly wanted to show you guys how to build a simple series circuit using a breadboard. We haven't talked too much about building necessarily on the breadboard yet, and I definitely want to show you how it would be done in real life if you were to have these components. So unfortunately, I don't have a 9-volt battery. That's what I would prefer to use. So I'm just going to power my breadboard through the Arduino. Okay, so an Arduino is a microprocessor that I'm going to plug into the computer and gain some power from that. Just think of this as the 9-volt battery setup. So when you're creating a circuit, the first thing you want to do is bring power and ground to the breadboard. So we talked already about the breadboard, how it has a channel going vertically, that's positive, and a channel going also vertically, that's negative. Those run parallel to each other. So the first thing you always want to do is bring power, usually the red wire, to one of the positive pins on your breadboard. And then I'm going to take my black wire and bring ground, or no charge, to the negative side of my breadboard. Now, just me putting this wire in that first spot on the positive side of the breadboard brings power to all of the other pins that are directly vertically in line with the red wire. Same goes with the black wire. Any one of those pins in the same vertical row as this black wire is ground, or has a net zero charge, 0 volts running through it. So once you kind of get that situated, I'm then going to start with my switch. That's just the order in which I decide to build it. Usually when you're using a breadboard, you want to put the switch across the middle channel, just so you don't get any interfering connections with any other positions on the board. Right now, there's nothing connected to this push button switch, so there's no direct correlation between those two points there. So I need to bring power to the switch. So I'm just going to use a red jumper wire, and you can use one of any color. And I'm going to stick one side in any of the positive pins, and then I'm going to stick the other side into a pin that's directly in line horizontally with that first kind of leg of the push button. So we have it connected. In the internal pins of the breadboard, not including the negative and positive sides, are wired horizontally. So all 5 of those pins wired horizontally are connected to each other through a metal strip under the breadboard. So right now I have the positive side of the wire connected to one side of the switch. Next, I always like to put my resistor before I put any LED. So I'm going to connect the other side of the push button switch to one side of the resistor. And then I'm just going to choose to put my resistor in to start a different row. You never really want to put a resistor or an LED or any component with 2 legs. You don't want to stick it in horizontally like this. Okay, if you stick things in the same row horizontally, power's just cycling through that piece. It's not moving or traveling to any other part. So I want to make sure that I connect those vertically. So now if we're tracing power, my power was in row 9. I know it's really hard to see because they're small numbers, but there are numbers and letters on your breadboard that tells you kind of what exact position your piece is stuck into. So right now on this side of the resistor, it's the power's running through row 9, and then I'm transferring by putting the resistor in vertically. I'm transferring the power to row 13. The next thing I'm going to do is I'm going to connect the resistor to the positive side of the LED. And I know it may be hard to see because, again, it's super small, but you have a long leg of the LED, which is over here, and then the short leg of the LED. If you remember from a few weeks back, the long leg of an LED is the anode or the positive side, and the short leg of the LED is the cathode or the negative side. So I want to take the long leg of the LED and connect it to my resistor. So as long as I plug it into one of the pins in row 13, because that's where we ended power, my resistor and my LED are connected. Last thing to do is connect the negative side of the LED or the cathode back to ground on our breadboard. Let's see if I can get this in a good spot. There we go. Okay, you could use a wire to do this. I just prefer kind of just sticking the components where they need to go. Remember, we put ground in this vertical row, the negative side of the breadboard. So I can technically get ground or 0 volts on any of those pins that travel vertically. So I just decided to stick the short leg of the LED into one of the negative pins on the breadboard. I'm going to bring power to my Arduino so we get something going. So remember, if we were doing this together in class, you would be using a 9-volt battery. So just pretend like this is a 9-volt battery over here. Now, essentially, if I were to push the push button, the LED should turn on. So let's see if it works. LED turns on, LED is off.